At this point, you should have mastered the art of triangle solving. Given any triangle and three parts, there are three angles, three sides, so any three of those parts, you should be able to find the other remaining parts, angles and sides, and its area. With the exception of given all three angles. That's not good enough because similar triangles have the same angles, so that AAA is not ever enough info. Anyway, what we're going to do now, naturally, to make it mean something, is set these triangle problems to a story. Models is the word that I should use, but I'll just call them word problems because that's what they really are. Some people see the words word problems and think it's going to be horrible. So if you prefer, you can say models. But this just means let's make it stand for something, not just a triangle drawn on a paper. There's a couple of cool applications of how you can measure distances out in the real world that you can't just use a tape measure. So here's an example. If you need to measure across something and you can't walk across it and count your steps or extend a tape measure across it, like a body of water or in this case a swamp with a creature living in it, what you can do is you can walk off some distances, and if you can measure the angle, then you can use your new tools, law of sines, law of cosines, to find some missing distances. So what I want to know here is how far is it across the swamp? I'm not going to get in my little boat and mess with this creature. I can't walk across it. So what I can do is walk on dry land 37 yards, and then walk to the other corner 31 yards. I'll mark this point out here. And it'll be, if I can measure my angle, that's 51 degrees. So those are things that you could reasonably do in the real world. And now if you know these three parts, side, angle, side, you can use that info to find the distance across this swamp that you were not able to measure directly across. So again, with side, angle, side, I'll say, let's use x squared equals 37 squared plus 31 squared minus 2 times 37 times 31 times the cosine of 51 degrees. The 51 corresponds to the x because it's across the triangle. All right, so this is a kind of an easier application of the law of cosines because we don't have to use the quadratic formula. So I can just pretty much put this straight into my calculator. 37 squared plus 31 squared minus 2 times 37 times 31 times the cosine of 51 degrees gives me 886 yards. All right, this would be a common mistake to leave this as your answer. That's not reasonable if you look at your picture. Right? There's no way that that's 886. Forgetting to square root, common mistake. My point in this is always check the validity. Are your answers somewhat reasonable? Not all pictures are drawn to scale, but you should have some red flags if you get an answer like 886, and we were just dealing with numbers like 37 and 31. All right, so we'll call it 29.8 yards, and that is a reasonable number. So you can measure a distance in that way if you're able to step off or measure a couple distances on dry land and get the angle in between them. Here's another classic example. It's inspired by this old photo I found at home. That's my grandma, and that's I'm in the back of that old car driving through a redwood tree with my grandfather. And so inspired by that, we're going to do a redwood height problem. What if you have a giant tree? You need to measure how tall it is. This is a common one you'll see in a textbook about how tall is a mountain, that sort of thing. And this one actually is going to involve right triangles. The last one did not have a right angle. This one does. So if you're able to measure the angle of elevation, which is how many degrees you have to look up to see the top of the tree, then move a little bit closer to the tree, in this case 42 feet, look up again and see what the angle is. We should be able to estimate, or if these numbers are accurate, we'll actually find the height of the tree. All right, so this one's definitely not to scale, but we'll use the 81, the 74, and the 42 feet. This one, you'll recognize it when you see it. There's a couple of ways to go about this. These triangle problems, a lot of times they'll have several answers that work, several paths to the right answer. Here's just one way to get this one. I'm going to call this distance right here y. And we're going to have to, what we do not have so far is all of the, we don't have 3 parts of one triangle. I could say that this angle right here is, that'd be 99. And then I would have an angle side angle. Maybe I could do that to find some other lengths. Let's go. So I'm thinking as I get to looking at this one, this might be an easier way than using this y. Let's do this. Let's go with this angle up here would be 180 minus 99 minus 74. Just make sure I don't mess that up. 180 minus 99 minus 74 would give me 7 degrees. And just a minute ago, I got that 99, by the way, because it needs to add up with 81 to make 180, to make the straight angle across the bottom. So how about this? What if I go sine of 7 over 42, and I'm going to call this side right here z now, equals sine of 74 over z. All right, so solving this proportion would look like this. Sine of 74 times 42 divided by sine of 7, cross multiply and divide, and that tells me that z is 331.3. And now I've got this little right triangle where I know the 81, I know the 331.3, and I'm looking for x. So with respect to 81, x is opposite, z is hypotenuse, so that means the sine is the trig function I want to use. Sine of 81 degrees equals x, which is the answer I want, over 331.3. So 331.3, the answer I just got, times the sine of 81 should be my answer. All right, if you ever can, use all the decimal points of that answer that you just had just by using the answer feature of your calculator, and that'll improve the accuracy of your final answer. So I get 327.2. Big tree. And this one, I had a different plan when I started talking about this problem. This one actually is quite a bit easier. I'll show you, since I've got a little time, how you could also solve it using y in a completely different method. So what I had planned to do was come up with an equation using tangents. The tangent of 74 is equal to opposite over adjacent. That's x over y plus 42. And that's true and that's good, but I have an x and a y, which is a problem. But then I know if I have 2 unknowns, I need 2 equations. My other equation would be the tangent of 81 degrees equals x over y. So now I have 2 equations, 2 unknowns, and I can do a little substituting and solve. And let's see, over here I can make it y times the tangent of 81 equals x, and then take that and put it up here. So tan 74 equals y times the tangent of 81 over y plus 42. All right, now I can multiply both sides by y plus 42 to get it off the bottom on the right. Remember, tangent 81, tangent 74, those are just numbers. That I can do the algebra as if I had a 2 or a 3 sitting there. Let's see. I've got y's on both sides, which isn't great yet. So I'm going to distribute this tangent on the left. here and here. Okay, now I've got, I'm going to move my y part over to the right and make this side just 42 tangent 74. And over here, y tan 81 minus y tan 74. Okay, I just subtracted this term from both sides. Now I can factor out that y. And when it's all said and done, this divided by this should be my final answer. And this is going to be foolish if it doesn't match the answer we just got, but I think we're pretty safe. So on top, I've got 42 tan 74 divided by tan 81 minus tan 74, fingers crossed, denominator in parentheses, 32.43 is y. Got nervous for a second. So remember, I had two equations, two unknowns. I found the first unknown, y, is 32.43. And somewhere up here, I should have x and y related. Now that number times the tangent of 81 degrees from right here should give me x. So times tan 81, again, fingers crossed, times tangent 81, 204.8. Of course it didn't work. Let me pause and figure out why. Okay, I don't have to scrap this whole video. I'm pumped. This actually will bring up a good point. Look here up on my calculator. I did tangent 81. It opens a set of parentheses when I do tangent. I typed the 81. I needed to close those parentheses before I did minus tan 74. So get rid of that. Now this time through, I redid it. I did tan 81 minus tan 74 with closed parentheses, which makes y equal to 51.8. 51.8 is now here. That times tangent of 81, 327.2. Oh, how tall is the tree? 327.2. Beautiful. Okay, now obviously I made that mistake just to keep you on your toes and illustrate a possible hiccup that you could make. I would never do that accidentally, but it also proves this point. There are sometimes easier ways than others. Up here in red, law of sines, piece of cake. Down here using right triangles, ugly algebra. A lot of possibilities for errors. All right, but either way, we get 327.2, the height of the tree. So there you go. So these are our models / word problems. And if you've mastered your triangle solving, these shouldn't be too bad. Just don't make little calc mistakes like me, young out.